Hello everyone. Today we will study acid-base and amphoteric equilibria and heterogeneous equilibria. Let's start from experiment A. 2 drops of methyl orange. It can be more, it's not necessarily exactly 2 drops. And some amount of water. As you see, the color is yellow. The color of a solution of methyl orange indicator. Then, if we add some amount of hydrochloric acid, color turns to pink, light pink color. So it's because hydrochloric acid is a strong acid and it's distillate to H plus cations. And this indicator, methyl orange, indicate this acid environment and change the color. Okay, another indicator, phenolphthalein. Phenolphthalein is a colorless indicator. And in aqueous solution is also has no color. Then we add some amount of sodium hydroxide. You can see the change of color from colorless to bright pink. It's also because sodium hydroxide is a strong base and is state to sodium cation and hydroxide anion. And this indicator, phenolphthalein, indicates the presence of hydroxide ions. Okay, next reaction, experiment C. We should obtain zinc hydroxide by reaction of zinc salt, for example, zinc sulfate, and sodium hydroxide. You can see this white precipitate. Zinc hydroxide is insoluble compound, insoluble in water. Next step, we should divide it by 2 parts. To 1 part. I will add hydrochloric acid solution, maybe more. And you can see this zinc hydroxide dissolved in acid. Because zinc hydroxide reacts with hydrochloric acid and forms some soluble salts. Then I add excess amount of sodium hydroxide solution to zinc hydroxide precipitate also dissolved because zinc hydroxide is amphoteric hydroxide and can react with acids and bases. So, no precipitation in this tube. Okay, you should also repeat this experiment with aluminum and copper salt. And if you cannot do this experiment, you should think about these compounds and try to think about what can you observe in this reaction. For example, what reaction will be with aluminum or copper hydroxide with excess amount of sodium hydroxide. I think the results will be different. Okay, next experiment. Let's mix a solution of hydrochloric acid with sodium acetate. I can't see any changes, but let's try to taste the smell of the product of this reaction. If you try to taste the smell of the product of this reaction, you can taste the smell of vinegar, the smell of acetic acid, the product of this reaction. It's because the acetic acid is a weak acid, and then sodium acetate react with strong acids like HCl. The product of this reaction will be acetic acid, and the smell of vinegar, I think you know what smell is it. Okay, next reaction. Let's mix hydrochloric acid with sodium carbonate. I don't know, will you see the product of this reaction, but let's try. The product of this reaction is some bubbles. Let's repeat this experiment. Maybe I will use 2 tubes. In one tube, I will add sodium carbonate. On another tube, I will add hydrochloric acid. And we'll repeat this experiment near the camera. Let's try to do it. Okay, it's a good reaction. These bubbles indicate about carbon dioxide gas, the product of this reaction. It's because carbonic acid is also weak acid, but it's unstable in water, and true product of this reaction will be carbon dioxide gas. And last reactions. Last reaction, reaction between barium chloride and some sulfate, for example, sodium sulfate. You can see milky white product of this reaction is a barium sulfate, is an insoluble compound. So the product of exchange reaction between barium salt and some sulfate will be barium sulfate, milky white insoluble compound. Okay, please try to complete all equations. And if you have any questions, please ask me about it.